Okay, so we're picking up on 7-2, the rational exponents. So we're going to pick up on B here, is where, if my marker will work, is where we left off. All right, so we've got 216x to the 9th over 125, and all of that is raised to the 1/3 power. Okay, so you're good? You don't want to have to do that? Okay, fair enough. Sometimes, like we're working with exponential expression. Would it help if we went back and looked at A first to get us back into it since we've had the weekend? Okay, since we did that one. All right, so we said, well, this was 1.5. We changed that to a fraction. What fraction was 1.5? Okay, 3/2. All right. And then if you recall, we tried to change our coefficient and our variables to numbers that would cancel with 2, with a denominator of 2. So we said, well, this 36 was the same thing as 6 squared. And then we left a to the 6th was fine, right? And b to the 12th was fine. But the reason, and so this is all raised to that 3/2 power. And the reason we did that is because this 3/2 is distributed to each of these parts. So we had 6 to the 2nd power times 3/2. And then a to the 6th power times 3/2. And then b to the 12th power times 3/2. So now we could cancel, right? The 2, because this is 2/1, cancels, which leaves us with 6 cubed. The 6 becomes a 3, the 2 becomes a 1. So this was with a to the 9th, 3 times 3. The 12 would become a 6, the 2 cancels, so this is b to the 18th. And then to finish that up, we needed to do 6 cubed, which was 216. A to the 9th and b to the 18th. And we had some absolute value signs in there because a was positive and now it's negative. Okay. All right.
But if it's negative going to a negative, not a negative, I'm sorry.
I mean,
yeah,
it's an even going to an odd.
Yeah,
Geez, not a positive. Yeah.
So an odd going to an odd, you don't need the absolute value.
Nope. Nope, because it's all about how the exponent changes the value of a. Because if we have an even exponent, it'll come out the same. Or it could be either or. If it has an odd, if you put a negative number in, it's going to be a negative number.
Yeah, that makes sense.
Okay. Okay. So since we redid a, and we're looking here, and our exponent is to the 1/3 power, what should we be trying to get our exponents to in this case? A multiple of 3 is what we're kind of looking for. All right. Yeah, nice. Yeah. So we could
216 we can see from the left side is 6 to the 3rd.
Ooh, 216 from the left side. Look at that. See, we can see right here, right? Make that connection is 6 to the 3rd. So we don't even have to do the work to find it. All right, so we're going to have 6 to the 3rd, x to the 9th over 5 to the 3rd. Again, if you're not for sure where we're getting these, right, so we can take 125 divide by a prime number. So we got 5. And then 125 divided by 5 is 25. We can divide that by 5 and we get another. So there's our 5 to the 3rd to help us. All right, so all of this is raised to the 1/3 power. All right, so Brandon, help me with that. Now I'm going to have 6 to the 3rd times what? Remember, this distributes. 1/3. Good. Ethan. I'm going to have x to the 9th.
I was still writing, sorry.
Okay.
What do you want?
I'm going to have x to the 9th times what?
1/3.
Times 1/3. Okay. And Josh.
5 cubed to the 1/3 power.
Okay. Well, I didn't change color here. All right, so now I'm going to have 5 cubed times 1/3. All right, then Brandon, what happens next? I multiply. Okay. Or
Well, don't all the threes cancel first.
so and it depends on how you look at it. 3 times 1/3 is just 3. Or is just 1, right? So the 3's cancel here. So we have 6.
To the x to the third.
So we're going to put 3 here, and this would become a 1. So it'd be x to the third.
Over 5.
The 3's would cancel, and we would have 5 in the denominator.
Is that the answer?
This is the answer. You can write it like this, or you also have the option of saying, okay, well, this is 6/5, and then pulling your x cubed over to the side if you would rather. Either of those is perfectly fine.
Wait a minute, why you can do that? Are they not both divided by 5? How can you just pull the x cubed? There's nothing.
Because it's the same as saying like 1 times 12 divided by 2, or 1/2 times 12. Because it's multiplication, so it doesn't matter what order we do it in. So 1 times 12 is 12. 12 divided by 2 is 6, or 1/2, which is 0.5 times
So
12 is 6.
No, but that's dividing.
Okay. Because you've probably done it a lot with like slope-intercept form, like when you have y equals 1x, or we have a lot of times, let me go back, there we go. You have x divided by 3 plus 7, and that's not really slope-intercept, and we say, well, that's the same thing as 1/3 x plus 7.
I remember doing that. So.
It's the same thing. We just haven't seen it in a bit.
I'm trying to think of how it makes sense, because you're multiplying, then dividing, and on the other one, you're dividing, then multiplying. Does that make sense? I didn't think you could divide it in any order. But I guess you're technically not, right?
Yeah, you're technically not. Because, yeah, it's just...
And I get what you're saying by changing. I'm just trying to think, like, there's also division in there, how that actually works. But it's not a big deal.
Okay. We can come back and revisit it some more, too.
But it's good to know, at least.
Okay. All right, and so then let's go on to example 5. All right, so example 5, to simplify each radical expression. We're going to convert it to exponential form, apply the properties of exponents, and then convert it to radical form. Again. So this first one, we have the 4th root of 1024. All right, well, I don't know about you, but I got nothing on like converting that to exponential, right? Which means it has to have an exponent. So we're going to have to take 1024 and start some division by primes.
It'll be 6. No. Yeah.
2.
It'll be 6.
You think it's going to be what?
6.
6? What's 6? Like 2 to the 6th?
I put the 4th root back in my calculator.
No, it's not.
5 point something.
I was gonna say it's not 6.
You put the 4th root in your calculator and you get 5 something. Yeah, that's the thing. Like with your calculator, they can be helpful, but they're not very helpful at this point. Okay?
So it'd be 512.
Okay, so not 512, right? Okay, I thought you said 502, and I was like, oh, just a second. Okay, we're going to divide by 2 again because it's even.
2, 5, 6.
Okay, we'll divide by 2 again.
1, 2, 8.
And it's still even, so we divide by 2 again.
4. Divided by 2. And from that point, we're going to have 6 more 2's. You just say it's like 6 more. Because it's 8 times 8. And to get to both of those, you're going to need 3 2's from each. So
You're good. So how many 2's was it? It's like the Tower of Babel right here. 10 2's. All right, so we've got the 4th root of 2 to the 10th. Okay, so how is that helpful?
Well, can we take some out?
Can we take some out?
Because there's 2 sets of 4 2's.
Okay.
And we have 2 left over.
Well, I was just going to say we could change it to 2 times, wouldn't it be just easier to pull it out and then reduce it?
Well, I'm just showing where it is. This is there's a couple different ways to do this.
I was
So
gonna say you could just do 2 times, or 2 to the 10th over 4 root, and then just reduce it to 5 over 2. Right? Or is that not what we're going for?
okay, so yeah, not quite. So I was gonna we're gonna finish this. That's fine because like you said, we could bring 2 out, another 2 out, and then we would have the 4th root of 2 squared. Okay, which would be 4 to the 4th root of 4. However, this is not simplified because, like, so part of the thing is we're supposed to convert it to exponential form, which we still have not done. We did give it an exponent, but we didn't convert to exponential form. Exponential form is what we had in example 4 above. That's it, and I will check it in a second.
By doing, because remember, so if we have like a number to the 1/2 root, like let's say it's a to the 1/2, you put the 2 over here and multiply it by the 10. So I'm saying you can take it, the 10 out and the 4, and you'd have 2 times 5 halves. Is that like power or whatever?
You mean, okay, so you're saying, so to the 10, okay, so you,
10 over 4, and
okay.
Reduce it, right, to the 5. Yeah.
Yes, okay, so that's what
we're going for, isn't it?
That is what we're going for, yes. Okay, but I was like, I didn't catch all of it when you were talking because I was still listening to Ethan, and I was like, I don't think, because when you said take it out, I thought you meant like take these out.
No, yeah, I was meaning.
Okay. So yeah, so here's the thing. In order to actually simplify it, we're trying to also simplify the radical and get rid of the 4th root if possible. So in changing it to say, okay, this is my power, this is my index, that's the same as 2 to the power of 10 divided by 4, which can simplify to 5 over 2. How do we think about that?
Well, you should remember how we saw it on the other side. We're just like basically doing the opposite of doing that.
So like what we did at example 4, right, where it was already in that exponential form, we're using that exponential form to help us simplify. I'm going to pause this for a second.
Maybe.
Okay.
I'm just confused on why we're doing it like that.
Okay, so if we take it further, we'll see how the answers are different. Because right now, this is kind of as far as we could get to with that strategy and leaving it in radical form. Okay, if we change it to the exponent form, then we could say, well, this is the same thing as 2 times 2 over 2. Why would I want 2 over 2? You don't know? Okay. Well, I'm not done. So let me finish. Maybe if I said 2 over 2 plus 1 over 2. Does that make more sense? A little? Brandon is saying no. Okay, so Brandon, if I took this back to radical form for a second, it's the square root of 2 to the 5th, right? Which is the same thing right here. This? Okay, I got it from the 10 to the 4th. 10 divided by 2 is 5. 4 divided by 2 is 2. Okay, so that came from here. Because we said, since we had the radical, right, and wrote it as that exponent. Okay, so are you good so now? Okay, so if we go back to radical form to try to make it make sense, if we said 2 squared times 2 squared times 2, because this is a square root, we could pull out a 2, take out another 2, right, for these two, and then we have the square root of 2. That's what we're doing here. So now we have 2 to the power of 1, which is just 2, and then plus 1, and then plus a half. So what's 1 plus 1? So now we have 2 squared plus 1/2. That looks a little big. Maybe I should erase it. Okay. Well, and so then we have to put it back into radical form, which this is a perfect time to do this, right? Because we want 4 times the square root of 2 is our final answer. So you could, after you get it simplified here, you could put it back in radical form and do it. But because this, I think, gets really kind of ugly and hairy. Yeah, because otherwise it's 2. So here, 2 squared is 4. And then it's plus. So then we have 4 times the square root of, let's see. Let's go back. We can't write the square root necessarily just yet. So it's 4 times 2 to the 1/2, which is 4, and then we do the square root, put our index in there, of 2 to the first power, or 4 times the square root of 2. So we can do it all out like this example here, or once we simplify it, we can go ahead and put it back in radical form to simplify it. I know, it's really kind of ugly. Do you have it written down? Okay, I'll let you copy it down. And then I think once we do another one, it'll help clear some things up. Okay, so now let's give B a shot. So what do you think? Let's change B to exponential notation.
So it'll be 2 times the square root of 2.
Okay, so let's just keep it with 8 first.
Yeah.
And so what would its exponent be?
2. Or it would be square root of 8 to the 1 power, which would be 1/2.
Okay, so it'd be the 1/2 is its exponent.
Okay, so we do want to do that first. We don't want to find the square root even if we can.
Yeah, well, I was going to say, let's see if we can just do this part first. Maybe that would make it easier. Do we understand where we got 8 to the 1/2 power? Okay, so 8, right, we have the square root of 8. Okay, so what exponent is on the 8 right now? There isn't one. Well, there is one, but we don't ever write it. It's kind of like when we write a number, a whole number. We never write the denominator. It's just 1. Okay, and so in a square root, what's the index? A 2. Again, we don't write it, but it doesn't mean it's not there. So this is where we got 8 to the 1/2 power from. Does that help? Okay. All right, and then we have the cube root of 4. So again, what's the exponent to the 4? A 1. Okay, so this is going to equal 4 to the 1/3. All right. Does that make sense so far? All right, so now let's see what we can do with those. How can we simplify 8 and 4?
Do we get common denominators?
Well, common bases, like we are trying to, just like we did 2 to the 10th over here. Yeah. So how can we simplify 8? 8 is equal to what squared or what cubed or what to the 4th?
It'd be 2 times the square root of 2. Is that what you're asking? Yeah.
So like if we 8 divided by 2, we would get 4 divided by 2 and 2. So we'd get 2 to the power of 3. Okay, so 8 is 2 to the power of 3. And then this is to the 1/2 power. Okay, Ethan and Brandon, how are we doing? Are we good with 8 is equivalent to 2 to the 3rd? Ethan? Okay. So then 4 is equivalent to what? 2 to the 2nd, or 2 squared. All right, times 1/3. So what can we do with these exponents that are being multiplied by each other?
I don't know, but we should be able to do something because.
Okay, so do they cancel?
No.
No, so then this is just 2. 3 times 1/2 is 3/2 over. Do these cancel?
No.
No, so it's 2. 2 times 1/3 is 2/3.
And then they're what is it called?
Reciprocals. But the exponents are reciprocals of each other.
Yeah.
But what do we do when we have, like, what do we do with the exponents when they're being divided? We have the same base. Like if I have x to the 5th divided by x cubed, we subtract them, right? That's the same thing as x to the 5 minus 3, which equals x to the 2. So since we have the 2 as our base, we can do that same thing. This is equivalent to 2, 3 over 2 minus 2 over 3.
So it'll be.
Or we would need to get them both to 6, you said?
9/6 and 6/9.
Not 6/9. You want them to 6, 4/6.
Oh, yeah, 4/6. My bad.
You're good.
Yeah.
Okay, so we had to get common denominators in order to subtract them. Do you remember all these things from like 6th grade math, 7th grade math, 8th grade math? It's like, oh my gosh, we're bringing them all into this one thing. Okay? Yes, I will, just a second. So what's 9/6 minus 4/6? 5/6. So this is kind of like, okay, we're almost there, except we want to put it back into radical form. The 6th root of 2 to the 5th, or the 6th root of 32. Okay, and then there are all these properties there to help remind you of all the different ways that you can use them. Okay, you can use these properties to help you simplify expressions with rational exponents, radical expressions, or however you can do it. And we will be doing addition, subtraction, and products of these over the next few days as well. So it's not the funnest stuff, right? But your homework tonight is page 295, 296, wherever that is. I think it's 296 actually. Numbers 25 through 35. And then I added on some review today. 45 through 49 is the cumulative review. Maybe that'll light up your life a little bit.